Who would have thought when I was a kid complaining about math classes being early in the morning that I'd be up at 6 a.m. doing math? Crazy, huh? Anyways, I got to 13 yesterday before I left. 13 is a simplification process. You were supposed to take the cubic root of things. Some of this stuff you ought to know. And there's lots and lots of ways of doing these things, and some of you will get quite natural at it, and some of you are not that good at it. But, if you look at your individual pieces here, the cubic root of 27, that's a 3, because 3 times 3 times 3 is 27. And I don't guess that it matters how many times I explain that to some of y'all, you're just not going to get it. But I know there's going to be a 3 in my final answer. Now, let's look at some of these individual pieces, like this x to the 7th. That takes an x cubed, and an x. Well, each of these, the cubic root of x cubed, because we're thinking about power over root, that's x to the 3 over 3, which is just x to the first. So that creates an x, that guy creates an x, and I'm left with cubic root of x. So I'm going to gain an x squared here, because x times x is x squared. And now I'm also thinking about the cubic root of y to the 6th, which is going to be the cubic root of y cubed times the cubic root of y cubed. And each of those create a y, and y times y is y squared. Now the only thing left inside was a cubic root of x, which I cannot evaluate. There you go. It reduces down to 3x squared, y squared, cubic roots of x. Done. Moving forward. Convert the decade decay model, a sub t equals 35 times 0.97 to the t over 10, into a yearly decay model, and find the yearly rate of decay. So what matters here, and I think about half of you at this point in time have finally figured this out, is that we move the 10th piece in, and we keep the t on the outside. That'll make it a yearly model because that's supposed to be a 1. T is just in years now. And then you pull up your trusty TI-84, and you push some buttons, and you figure it out. All right, so let me pull up my calculator, because I have no idea what 0.97 to the 1/10 is. I don't know what the 10th root of that is. 0.97, if I want to take the 10th root, I raise it to the 1/10 power. Power over root. 0.99, look how that rounds. It's 6/9. That turns that 9 right here into a 10, which makes that round to 7. 0.9970. So my correct model is that after some time passes on the principle of 35 times 0.9970 to the t. Now, I want the yearly decay rate. Decay is modeled by a principal times 1 minus r to a t. So I just do a lineup process. 1 minus r is 0.9970. And, some of you will get this and some of you won't, but it should be 0.0030 because you do the math, right? You put the r on the right, this becomes 1 minus 0.9970, and I know you're going to be button pushers, but whatever. 0.0030 is r, so that means that r is 0.30%. Pick your poison on which one you want it to be. I don't care if you want the decimal or the percentage, I really don't. All right, moving forward. Given that f of 3 is a 0, f of negative 2 is a 0, f of 4 is a, well, there's a lot of zeros in here. What are the known factors? So these are created from zeros. All right, that's the main thing. That one's gone and that one's gone because they're not zeros. That's why I erased them. Now f of 3 says x is 3. If I just shift that 3 left, I have the factor. And that's what's happening. This sign is changing. You see, we were positive, now we're negative. Here's a 0. It's going to become x minus 4. There's a 0. It's going to become x plus 4. This one is something I've noticed it bothers kids. A lot of kids who it shouldn't bother, but it says x is 0. And if we just shift that 0 left, we'd have x minus 0. And x take away 0 is just x. So that one had 4 factors. Easy peasy, not hard. It'll be missed by many. Of course it will. All right, 16 is solve 4 log base 2 of x minus 3 plus 2 equals 16 by hand. And I think I want this to be an 18. I do. It was a basics quiz. It wasn't intended to be too bad. So let me modify that real quick. So by hand means you're not using Y1, Y2. And I understand that some of you will have to use technology to do evaluation, but you shouldn't on this one. Anyways, we're going to do the easy stuff first. Remember, it's always the easy stuff first. So we're going to take away 2 and get a 16. 4 times the log base 2 of x minus 3, and that's 16. Now we're going to divide out the 4. We'll have a log base 2 of x minus 3, and it's equal to a 4. And then we're going to go and we're going to think about the whole log as Bay conversion. A logarithm base b argument a equal to some e has an equivalent inverse of b to the e equal to a. So base, argument, exponent. So 2 to the 4th is x minus 3. 2 to the 4th is going to be 16. You can push buttons if you want to. You shouldn't have to, but whatever. And then we add 3 and we get 19. There's my x. 17 is a solve using tech, because they're kind of hard to do by hand, to be quite honest with you. And the reason these are hard to do by hand is because the bases aren't the same. And they get kind of rough if the bases aren't the same. So anywho, you just have to know how to put things in a calculator. That's really all there is to it. So this is going to be my y1. It's going to be 4, and I like the ln. ln's of 3x minus 4, and that's sitting pretty over the ln of 2, and then plus 5. My y2 is going to be the ln of 2x plus 1, sitting pretty over the ln of 7. If you want to use logs, whatever. I don't really care. You just do you, but make sure you're using correct change of base. All right, so I'm at y equals, I'm going to type some stuff in. Let's see here. The safest way to do this is to go to math, num, n over d. So that's where I'm going. We got 4 ln's of 3x minus a 4. Close the parentheses just like it was written. Sitting over the ln of 2. Then we're going to have to add 5 in. And then what do we got here? Back to math, back to num, up to n over d. We have an ln of 2x plus 1. And that's sitting pretty over the natural log of 7. And then we'll do the way you were trained. You were trained to assume 6. And there's your intersection. So second, trace, 5. Where's my cursor at? There it is. Get close. Enter, enter, enter. 4 decimal places. It's a 4 decimal place thing. 1.4918. 1.4918, because I'm looking right there. Not hard. Then there's this dude. This dude has really been messing with some of y'all. And it's not meant to. So some little notes here that we might need. A touch happens twice. They both start with letter T here, okay? A cross happens And the correct word is at least twice. At least once. So this is a touch. This is a touch. So x equals -1 has a multiplicity of at least 2. This is a touch. X equals 0 has a multiplicity of at least 2. And this guy is a crossing. It's crossing the x-axis. So x equals 3 has a multiplicity of 1. And this isn't a hard concept. Like this ought to be one of those things that only just the really, really special kids don't get. Like, everybody should get this. I don't understand why it's being such an issue. I mean, it's got to be apathy, right? All right, 19, degree in the sign of the polynomial based on n behavior. Oh, I can think of some honors kids who just can't figure this out. God bless you. Like, it's not hard either. Like, the very first day of class with me back in August, I was having you guys do this stuff. X to the even. How's it start? Starts high. How's it end? High. X to the negative even. How's it start? Starts low, ends low. X to the odd. That starts low, ends high. Negative x to the odd. That starts high, ends low. Think about your hands, kids. We got up and we did these things. We stood up and we worked our way through them. And what happened? Anyways, bruh, this thing starts high, ends low. Now, what does that look like? Something that starts high and ends low? It looks like this dude. So this is a negative x to the odd. Now, speaking of negative x to the odd, 2 plus 2 plus 1 is 5, which is odd. Least degree of the polynomial based on turning the point of theorem. These are kind of small. 1, 2, because notice it goes from up to down, 2, 3, 4. She has 4 turning points. So 4 TPs. So the degree is 4 plus 1, which is 5. We add 1 to the number of turning points. By the way, 2, 4, 5. 5. Look at that. 2 plus 2 plus 1 equals 5. Notice how they match. Do you see that? They match. Who'd have thunk? Right? Known factors. It says multiple select, but I have no idea if it's going to be multiple select or not. So I have x equals -1, that's x plus 1, and it's going to be squared. I have x equals 0, and again, that's x minus 0, which is just x, multiplicity of 2, so it's squared. And then I have x equals 3, which is x minus 3, because for the bajillionth time, when a number enters parentheses, its sign changes. It's not rocket science. All right, so 22 is to find the factored form of the polynomial. I didn't label this point here, but I'm quite certain that point is at 220. Sure looks like it's at 220. We're going to call it 220. All right, 220. Actually, that is not at 220. No, it's not, is it? Huh. Bummer. Wish I knew what that was. Let me pause this real quick and go back and get the original so I can see. All right, so I had to look it up because I didn't copy down one little thing. This point, which is at 218. That's what I needed, 218. So let's start writing some stuff down. Our equation, as we know, is some letter A times x squared times x minus 3 times x plus 1 quantity squared. And we have 218, which gives me an x and a y also for the bajillionth time. So 18 equals a times a 2 that is squared times a 2 minus a 3 times a 2 plus a 1, because what I'm doing is everywhere that I see an x, I'm letting it be 2, and everywhere I see a y, I'm letting it be 18. And then I do math. Like this guy is 3, and 3 squared is 9, right? 2 minus 3 is -1. Awesome. 2 squared is 4. Still equal to an 18. 4 times negative 1 is negative 4 times 9 is negative 36. This is not complex. We divide both sides by a negative 36, and then we reduce. And we get that a is negative 1/2. So my full equation is y equals negative 1/2 of x squared. Don't need that parentheses there. X minus 3, and then x plus 1 quantity squared. All right. Now for the stuff that some of you aren't going to do. These two bonuses are solve 100% by hand. The first bonus is not hard. What we're going to do is we're going to put logarithms on one term. We're going to kind of think like terms on one side. That probably works for 90% of the stuff you do in this class, like terms on one side. So we have a log base 2 of 4x plus of 3. We're going to take away a log base 2 of 2x plus 8. And this is not a like term. It's not a logarithm, so it's going to shift right. Now, log of a over b is a log of a minus a log of b. These are properties that, you were supposed to memorize, but you won't. So I can do a condensing. I have a log base 2 of 4x plus 3 sitting pretty over 2x plus an 8, and it's equal to a 5. I have a lonely logarithm that has a base, it has an argument, which means this must become an exponent, and I get to do good old log is b. So 2 to the 5th is equal to 4x plus 3 over 2x plus 8. 2 to the 5th is 32, and it's equal to 4x plus 3 over 2x plus 8. We'll put that 32 over 1. I'm going to do something called cross multiplication. So 1 times 4x plus 3 is 4x plus 3. 32 times 2x is 64x equal because there's an equal to symbol. 32 times what? 8? 240, 256. And then I'm going to put x's on one side, numbers on the other. And that's what I'm going to do. I'm pretty sure I'm going to get an extraneous answer. I am. I'm going to do all this work for absolutely nothing. 3 minus 256 is negative 253. Divide out the 60, and this is my answer. The problem is it doesn't work. A logarithm of base a, of argument a, the argument must be bigger than 0. And if you plug that in there, you would be feeding this thing a negative entry. It'd be a big old number too, but it'd be negative. Like it's going to have a log base 2 of some negative number, and it's just not going to work. So all that work for an extraneous answer. Doesn't mean it wasn't worth doing. It has no solution. If we looked at the graph, they don't cross paths. All right, the other bonus, which is way more difficult, so therefore it's going to be worth way more points, because it's kind of a rough thing. These two, they don't have the same base. Only a math major or a STEM major is really going to have to know how to do this. And I would debate on whether a STEM major does. But they don't have the same base, which is the whole frickin' problem. But anyways, we're going to go through the basics of it. We're going to put our logs on one side. One plus 3 is 4. And I cannot put these together because they don't have the same base, so they cannot be easily condensed. Notice I said easily condensed. What I'm going to do is I'm going to rewrite the second one as a base 4 log. So we got log base 4 of 8x plus 2 minus change of base log base 4 of twice x over log base 4 of 16, and that's still equal to 4. Now, log base 4 of 16 is something that Milbrath taught you to evaluate. Log base 4 of 16 says what power of 4 is equal to 16? The answer is 2, right? So, log base 4 of 8x plus 2 minus log base 4, oh, no, sorry, yeah, log base 4 of twice x, sitting pretty over 2 is 4. Now what we're going to do is we're going to clear the fraction, and then I'll be able to condense. So I'm going to 2 everything. As long as you do the same thing to everything, at least with multiplication, you're okay. Like you can't square everything, it'll be the same. You can square left to right. Anywho, 2 log base 4s of 8x plus 2 minus a log base 4 of twice x is now 8. This 2 I'm going to put right there. Oops. Anyways, I moved it right there. So let's see what we have now. We have a log base 4 of 8x plus 2 quantity squared. Take away a log base 4 of twice x, and that equals 8. We can now condense. Remember, we condense subtraction with division. And now we can do some more math. And this thing just keeps getting hideous, right? It just keeps getting worse and worse and worse and worse and worse. I'll be happy if one kid tries to figure this out, to be honest with you. All right, so the first thing you got to do is 4 to the 8th, which is this morning beyond my calculations. At least mentally. 65, I knew that too, 65,536. So base, argument, exponent, 4 to the 8th equals this ugly, ugly thing, 8x plus 2 quantity squared, which I'm going to have to go ahead and take care of. 64x squared plus 16x plus 4, sitting pretty over twice x. That seems right. No, it's not 16x. It's 32x. Bad Milbrath. All right. To save some space here, because I know you have so much room on that piece of paper. We're going to cross multiply again. Double that. And I don't want to make any mistakes. So times 2. 131.72. X equals 64x squared plus 32x plus 4. Oh, it just keeps getting better, doesn't it? Shift this over here. 32 minus that guy. Negative 131, 40x on the right. And now what do? Well, you could probably make the numbers a little smaller and see if that's divisible by 4. It was. It's nice. So I can pull a 4 from everything, and that'll make the numbers a little bit smaller. 0 equals 4 times 16x squared minus whatever that number was, 32,760. And then plus 1. Now, this thing is not going to factor. It does have real answers, though, which is kind of cool. A is 16, B is negative 32,760, and C is 1. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. Now, really about the only thing you're going to be able to do on this is see what's in the radical. So we've got that guy squared minus 4 times a, which was 16, times c, which was 1. What a funny number. Now, maybe it'll simplify. Let's see. Let's see if it's divisible by 64. It was. Cool. Let's see if it's divisible by 256. It was. Awesome. Let's see here. What's something else we could do? It's not going to divisible by 1,000 or anything like that. Okay, well, let's just go back to this. That was 256, right? Whoops. Let's see if it's divisible by 256, because it ends in 256. Nice. So 256 entered this thing twice. What happened again? No. Here's what I know. It's 256 times 256. See if it's divisible by 16. No. Is it divisible by 4? It is. Cool. We got 4,094. I was really thinking, I don't know, it just seemed like it'd be divisible by 4 again. All right, so it's even. It's not divisible by 16. It wasn't divisible by 4. What's the next even number you can take the square root of? 36? No. I really feel like 4,094 ought to simplify some more. You know, your squares are 4, 16. Of course, then you got your odds like 25, which isn't going to enter it. 36. 64. 64 probably not going to happen, but it might. After 64, you jump to 100, and then you jump to 144. No. And after 144, what's your next nice square? It's 256, isn't it? It's 14 squared. See if it's divisible by 14 twice. No. I think that's where it stops. All right, so we have 16 and 16. We have a 2. That's 256 times 2, 512 square roots of 4,094. So 32,760 plus or minus 512 square roots of 4,094. Both pieces over 32. So wait, there's more. 32,760 divided by 32. Doesn't happen, but probably reducible fraction. Really, that doesn't make much sense. 32,760, is it divisible by 4? 8,190 over 8. So is it divisible by 2 again? 4,095 over 2. All right, we got 512 over 32. Oh, it's just 16. All right, so this one's real because a logarithm has to have positive, and that guy is the extra. So, yeah, I probably just wasted a whole bunch of your time. Lord knows I wasted a whole bunch of my time. But Maddie was like, how to do this. Maddie was curious how to do a problem like that. And there you go, Maddie. That's basically for you. Hope you enjoyed.